Module 2. Conducting Measurements. In chemistry, measurements are critical for understanding the properties of matter and how it behaves. The accuracy and precision of these measurements can have a significant impact on the conclusions that are drawn from experiments. Therefore, it is essential for chemists to understand the concepts of significant figures, scientific notation, units, and prefixes. Significant figures. Significant figures are digits in a number that are known with certainty plus one uncertain or estimated digit. They are used to express the precision of a measurement. For example, the number 3.14159 has 6 significant figures because all digits are known with certainty. In contrast, the number 3.140 has 4 significant figures because the last digit, 0, is an estimate. When performing calculations with significant figures, it is important to keep track of the number of significant figures in each measurement and to ensure that the final answer has the correct number of significant figures. This can be done by using rounding rules, which involve looking at the first non-significant digit and rounding up if it's 5 or greater. Measured numbers. Measured numbers are values that are obtained through the process of measuring, such as length, mass, and volume. These numbers are typically expressed with units, which provide a reference for the value being measured. Volume. Volume is the amount of space occupied by an object or substance. It is typically measured in units such as liters, cubic meters, or gallons. Weight. Weight is a measure of the force exerted on an object due to gravity. It is typically measured in units such as pounds or kilograms. Length. Length is a measurement of the distance between 2 points. It is typically measured in units such as meters, feet, or inches. Mass. Mass is a measure of the amount of matter in an object. It is typically measured in units such as kilograms or grams. Size. Size refers to the physical dimensions of an object, such as its height, width, and depth. It can be measured in various units depending on the object being measured. Temperature. Temperature is a measure of the degree of hotness or coldness of a substance. It is a physical property that can affect the behavior of matter. Temperature is typically measured in degrees Celsius or degrees Fahrenheit, but in scientific applications, the Kelvin scale is used. The Kelvin scale is an absolute temperature scale where 0 Kelvin represents the lowest possible temperature or absolute zero. At absolute zero, the particles in a substance have minimal energy and motion. The Kelvin scale is based on the same size units as the Celsius scale, with the difference being that 0 degrees Kelvin is equivalent to negative 273 degrees Celsius. To convert between Celsius and Kelvin, add 273 to the Celsius temperature to get the Kelvin temperature. Units and prefixes. Units are standard measurements used to express quantities such as length, weight, and volume. In the scientific community, the metric system is used, which is based on multiples of 10. Some commonly used units and their symbols include meter or lowercase m for length, gram or lowercase g for mass, liter, capital L for volume. In addition to the base units, prefixes can be used to express values that are smaller or larger than the base unit. Some commonly used prefixes and their symbols include kilo or lowercase k for 1,000, milli or lowercase m for 0.001, micro or mu for 0.000001. Using these prefixes can help to simplify measurements and make them easier to work with. Conversion factor. In the metric system, a conversion factor is a ratio that relates two different units of measurement for the same quantity. The conversion factor allows us to convert a measurement in one unit to an equivalent measurement in another unit. For example, the conversion factor between meters and centimeters is 100 centimeters per meter, or 1 meter equals 100 centimeters. To use a conversion factor, we multiply the measurement by the conversion factor. For example, to convert 2 meters to centimeters, we multiply 2 meters by the conversion factor of 100 centimeters per meter. 2 meters times 100 centimeters per meter equals 200 centimeters. This means that 2 meters is equal to 200 centimeters. Similarly, to convert 50 centimeters to meters, we use the conversion factor of 1 meter per 100 centimeters. 50 centimeters times 1 meter per 100 centimeters equals 0.5 meters. This means that 50 centimeters is equal to 0.5 meters. Conversion factors in the metric system are based on the relationships between different metric units, which are related by factors of 10. For example, the relationship between meters and kilometers is based on the fact that 1 kilometer is equal to 1,000 meters, or 10 to the third power meters. This means that the conversion factor from meters to kilometers is 1 kilometer equals 1,000 meters. Similarly, the relationship between grams and milligrams is based on the fact that 1 gram is equal to 1,000 milligrams, or 10 to the third power milligrams. This means that the conversion factor from grams to milligrams is 1 gram equals 1,000 milligrams. Place value. In a whole number, the value of a digit is determined by its position relative to the rightmost digit, or one's place. For example, in the number 345, the digit 5 is in the ones place, the digit 4 is in the tens place, and the digit 3 is in the hundreds place. This means that the digit 5 has a value of 5, the digit 4 has a value of 40, and the digit 3 has a value of 300. In a number with decimal places, the value of a digit is determined by its position relative to the decimal point. For example, in the number 2.347, the digit 7 is in the thousandths place, the digit 4 is in the hundredths place, the digit 3 is in the tenths place, and the digit 2 is in the units place. This means that the digit 7 has a value of 0.007, the digit 4 has a value of 0.04, the digit 3 has a value of 0.3, and the digit 2 has a value of 2. In decimal numbers, the digit to the right of the decimal point represents the tenths place. The second digit to the right represents the hundredths place. The third digit to the right represents the thousandths place, and so on. The position to the left of the decimal point represents whole number values, starting with the ones place and continuing to the left with the tens, hundreds, thousands, and so on. Scientific notation. Scientific notation is a way of writing numbers that are either very large or very small in a concise and standardized manner. It involves expressing a number as a coefficient multiplied by a power of 10. The coefficient is usually a number between 1 and 10, and the power of 10 represents the number of places the decimal point must be moved to get the original number. To express a number in scientific notation, follow these steps. Determine the coefficient. Identify the number between 1 and 10 that represents the significant digits of the original number. Determine the exponent. Count the number of places the decimal point must be moved to get the original number in standard scientific notation. If the original number is larger than 10, the exponent will be positive. If it is smaller than 1, the exponent will be negative. Write the number in scientific notation. Write the coefficient followed by times 10, wedge symbol, and the exponent. For example, let's express the number 6,200,000 in scientific notation. 1. Determine the coefficient. The significant digits in 6,200,000 are 6.2. 2. Determine the exponent. The decimal point must be moved 6 places to the left to get the original number in scientific notation. Thus, the exponent is 6. 3. Write the number in scientific notation. 6.2 times 10 to the 6th power. Here are a few more examples. 0.0000457. The coefficient is 4.57 and the exponent is -5. Thus, the number in scientific notation is 4.57 times 10 to the -5th power. 2,500,000,000. The coefficient is 2.5 and the exponent is 9. Thus, the number in scientific notation is 2.5 times 10 to the 9th power. 0.0032. The coefficient is 3.2 and the exponent is -3. Thus, the number in scientific notation is 3.2 times 10 to the -3rd power. Problem-solving skills. In chemistry, problem-solving skills are essential for interpreting data, performing calculations, and drawing conclusions from experiments. To solve problems in chemistry, it is important to break down the problem into smaller steps, identify the relevant equations and concepts, and use the appropriate units and significant figures. For example, suppose we want to calculate the volume of a cube with a side length of 5 centimeters. To solve this problem, we can use the formula V equals L to the third power, where V is the volume and L is the side length. Plugging in the value of L and solving for V, we get V equals 5 centimeters to the third power equals 125 centimeters to the third power. In this example, we used the appropriate formula and units to calculate the volume of the cube.